Good afternoon. Let's look at the implementation side of things a little bit now. So, Live Lab Data Workflow or LDW was an application that was built in phases. In phase one of the application, we actually focused solely on the case management of the live data side of things. So we talked, to the business about what exactly is it that we are trying to implement. What are the business requirements that we need to address using this application, and as a result, what should our case hierarchy look like, right? And what is the data structure that we would need to meet those business requirements. What we did not focus on this stage was the integration side of things. So, for example, we knew that there would be a system that would be creating this batch in Pega, but we did not really know what that system was or what type of integration we would be using when we were integrating with that system. Similarly, we knew once the sample intake was complete in our application, we would be sending a message to an external system to create or submit the sample in that system. But beyond that, we did not know how exactly that integration would be achieved. In phase two, our focus has switched from actually working on the case management and the live data side of things to actually doing integrations with these systems. So, for example, right now, we are integrating with a system called ELN, or Electronic Lab Notebook, which is initiating that batch in Pega using JMS messages. Similarly, we are actually going ahead and submitting a sample to another system of record called Lab Information Management System, which is responsible for sample processing after submission. In addition to these two systems, we've also discovered that we are actually we need to integrate with another system of record called PD Hub that references reference data for BMS. And this integration is something that we've achieved using REST services. So through this exercise, one of the things that we have learned is that your integration layer or your physical data model is something that is prone to change. So in our case, for example, we did not really know, it was an unknown, what we are going to be integrating with, and how many systems ultimately we ended up integrating was different than what was initially envisioned. But I think beyond that, it's not really very far fetched to say that we are integrating with these systems using a particular type of messaging or web service protocol, and that is something that's going to change down the line as well. So, what I'm going to be demoing today is how exactly we have used Pega Live Data to shield our application from some of these changes on the integration layer that can happen independently of the business logic that we are actually implementing in the application. In addition to that, I'm going to be also highlighting some of the powerful tooling that's available in Pega to, to make such an implementation easy and seamless. So let's jump right into it. What you're looking at right now is the developer portal of a Pega 7 application. This is where we go behind the scenes and create the configuration required for an application. We also call it the design studio. And it has a number of launching pads that can be used for application configuration. Some of those can be launched from these buttons on the left side. Two of the more interesting ones are cases and data. So let's look at both of them. Cases is what I'm actually using to define the various case types of my application and their corresponding stages and processes. So remember when I talked about us actually focusing on the case management side in phase one of the application? This is where we came in and created the required components and configurations for case management at that stage. So over here, for example, we defined four different case types for the application: the batch, container, aliquot, and tests. And we came in and defined the various stages and processes that would be associated with each of them using the case designer. The data designer is where I come in and define my data types. So these are the various data types that are defined in our application. And if I open one of them, it launches a data type viewer for me, which allows me to visually go in and define what are the attributes and functionalities that are associated with a particular data type in my application. So in this case, I'm looking at a batch data type. So one of the things that you will notice right from the get-go is I'm using a more visual representation for defining the data types of my application. And we believe this is more powerful than some of the traditional approaches that we use when defining data types, like thinking about classes and the properties and what exactly our physical data model in the database is looking like. Because this allows me to think about my business requirements and my domain when actually defining my data modeling layer, right? And we think that is more powerful because this allows me to create a logical data model which resembles more which is more in line with my business requirements and my my domain, and as opposed to what my physical data model looks like. And as a result, it is more adaptable to changing business requirements. So in addition to defining the various attributes for a particular data type that I'm doing over here in the composition section, I can also define things like where exactly this data is being sourced from, and view the various records this particular data type may have using some of these other tabs on the screen. But one of the more powerful tools that is also available when I'm configuring a data type is the data visualizer. Let me go ahead and launch it using this button on the top panel and show you what that actually looks like and what it does for you. So in this case over here, for this data type, batch, I have a list of containers that are associated with it, and I can see that in this composition section below. But in addition to the various other containers that are associated with this batch, I can also drill down into those relationships and see what those other data types house. So for example, over here, this batch has a list of containers, and I can see each of those containers has a number of aliquots, tests, ad hoc tests, etc. in it, right? And I can further drill down and see each of these aliquots is composed of a list of tests. So what the data visualizer is allowing me to do is not just review what the composition of a particular data type that I'm looking at is like, but it's also allowing me to see what are the relationships this particular data type has with some of the other data types and cases that are defined in my application. So as you can see, this is an extremely powerful tool that allows me to visually see for a particular data type what are the various relationships I have in my application and where it is available, what is its composition. This is something that we use quite a bit in our application, and we use it for understanding those relationships in our application. So let's now actually go ahead and run the application and see Pega Live Data in action. So I'm going to kick off the process by creating a batch, and the first thing that I'm prompted for is a project code. It's an autocomplete control, so I can just hit the down arrow and it's going to present me a list of all the project codes that are available for selection. Now, this information is being sourced using Pega Live Data, and let's see how it's happening behind the scenes, right? So when I'm getting a list of project codes over here, I'm defining a data page that has all the information that it needs to go ahead and source, that has that has the details of where this data needs to be sourced from. Data pages are the heart and soul of Pega Live Data. This is where I define where my information needs to be sourced from and what should be the format of that information after it is returned from that source. It is this construct or this rule that allows me to create that separation between my logical and physical data models and allows them to evolve independently, right? So let's look at how I create and define a data page. In this particular case, my UI needs a list of project codes for selection. So this control is asking this data page to return a list of project codes that the user can actually select from. The data page itself has two sections in its definition tab. The first one is the data page definition itself, which talks about what should be the structure of the information that is being returned. And the second is the data sources section, which defines where that data is being sourced from. So let's look at both these sections. The first one, the data page definition section, is talking about things like what should be the structure of that data, right? Is it a page or is it a list? In our case, it's a list of project codes. So it's not a single entry, but a list, and that's what's selected. The second prompt is for the object type, and this basically defines the format of that information for it to be consumed by the application. In this case, it's a class in the application itself, my logical data model, right? The third one is what is the edit mode for that particular data page? Is this information read only or is this information read write? And finally, I define the scope of the data page, which really defines, for example, is this something that's going to be used by a single user or is this something that's going to be shared by all users across the application? The data sources section is where it gets a little more interesting, right? This is where I'm defining where is this information being sourced from. So in this case, for example, I'm saying I'm actually going to be using a REST connector called project compound int to source this information. And once this information is retrieved, I need to use this particular data transformation rule called project compound int to go ahead and transform that information into the format that I need it to be. Right? So as you can see, from an application perspective, I'm just making a call to a data page to fetch information in a certain format, and it's the data page's responsibility to decide where exactly that information needs to be fetched from and how. And in addition to that, it's the data page that is responsible for transforming that information into a format that I need it to be. The data pages themselves are extremely configurable when it comes to data sources, right? So here, for an example, consider a scenario where I don't really know what the source for this data is. And instead of actually hitting that actual integration point, I need to go ahead and simulate this information. Now that is something that is as easy as checking the simulate data source box over here and defining one of the many data transformation rules that I can have to fetch or simulate this information. So I'm actually being returned some simulated data instead of going to an actual data source, right? So in this case, for example, I have data transformation rule that is responsible for going ahead and creating some dummy project codes for me that can be consumed by my application. I go ahead and save this rule, and as you can see, instead of giving me a live list of all the project codes that I can use from an actual data source, it's just creating a dummy list of 5 different project codes for selection. Now, okay, it is easy to use this data. It is easy to switch to simulated data or switch a data source. But what's the use of that in the real world? How does that benefit me, right? So in our case, the benefit was pretty obvious. We worked on this application without integrations in the first phase, and we wanted to go ahead and build out the workflow, the validations, and the UI surrounding it without actual integrations being in place. So in our case, the benefit was pretty obvious. We went ahead and simulated all this information using data pages, and then down the line, we were able to quickly switch over to using actual data sources without having impact on all that configuration we created on the workflow in phase one. But there are other uses as well, right? So think about a scenario where instead of us actually going and hitting this REST data, this particular data source, we need to switch to a different data source, right? Now, that switch would be as simple as changing this connector over here to point to a different data source, and everything else in the application remains the same, right? Think of another scenario where we are actually using this REST connector to make an integration call and fetch this information today, fetch this information from this data source today. But down the line, the organization standardizes SOAP service calls for its integrations, and REST is no longer really valid anymore, right? So the data source itself remains the same, but the integration type is changing. Well, that change again would be isolated to configuration of this data source on this data page as well, and everything else in my application continues to work the same. So instead of having a REST connector type, I would define another SOAP connector type over here, and I would define a data transformation rule to go ahead and map all that information in a format that can be consumed by my application. Everything else in the application continues to be the same. Let's consider another scenario where instead of using a single data source, I have multiple data sources that I can actually hit based on business requirements. So in this particular example, let's just say I have uh, two different data sources that I can hit for actually fetching these project codes, and the data source that I would be using at runtime would depend on the organizational unit of the user who's logged in. So at BMS, for example, the users can belong to two different units, CD or DPSNT. And my requirement is if the user belongs to a CD unit, he hits data source A that is fetched from one database. And if he belongs to a different unit, the data is fetched from another database, right? That kind of configuration can be easily achieved using data pages as well. So in this case, for example, I can define multiple data sources, and the minute I do that, it prompts me for a decisioning rule that checks under what circumstances a particular database or a data source should be used. So in this case, for example, it is prompting me to say when should the first data source be used, and I can define a decisioning construct over here that if it is true, then it's actually going to be using the first data source, and if it's false, it switches over and uses the second data source, right? So through these examples, what we have seen is using data pages, my application is totally shielded from all the integration requirements and changes that may be happening at the integration layer, right? And that is the power of data pages and live data in general. It is making your applications agile enough to quickly and easily adapt to integration and to integration types and physical data models that possibly can and likely will change and likely will change with time. That possibly can and likely will change with time. Let's now switch back to the application and continue the workflow. So I'll go ahead and select a project code. And as you can see, as I'm walking through each of these screens, instead of instead of me using a stuffed out information similar to data right now, I'm actually going ahead and integrating with actual data sources, but everything else in the application remains the same. So in this case, for example, I'm selecting project codes from another system of record. Test information is integrated, so it's actually pulling from a live data source as well. Select the courier information, hazards, and submit. So in this case, instead of this actually instead of me actually simulating that submission to the LIMS system of record, the submission is actually happening, and everything else in the application remains the same, right? So I mean, what we've just seen is the ability to go ahead and use live data to build an application which can dynamically and quickly adapt to changing integration requirements. Live data, but live data can be used beyond that. But we believe, but there are other uses of live data as well. In this case, for example, what we are looking at right now is a batch dashboard. This has multiple sections in it. It has sections for work list, for results that may be coming from LIMS, for actions that the user can perform, for work parties or users who may be associated with this case. This information is coming from multiple sources. The work list itself, for example, is coming from the cloud data store. The test results would be coming from a LIMS system. Other actions are coming from the cloud data store, and work parties. In this case, we just have the requester, which is storing the user profile, things like his phone number, his email address, etc. is coming from a user directory that is stored at BMS. So as you can see, this UI is fairly complex in that it is fetching information from various disparate sources and then aggregating all that information and presenting it in a single view. It would be pretty useful to have this view be agile enough to quickly adapt to changing integration requirements behind the scenes, right? So for example, over here, and that's exactly what we've been able to achieve with Pega Live Data. We've used, behind the scenes, we've used data pages for fetching and configuring all this information. And because we are doing that, if tomorrow, for example, the user information needs to be fetched from a different data source, that change would simply be isolated to updating that source in a data page that's defined to fetch that information. So as you can see, we can use data pages for really making our application totally agnostic to whatever is happening on the integration side. So what we just looked at was a real-world example of using data pages to solve some of the data modeling challenges that we have in enterprise applications today. In addition to that, we also saw that live data is extremely powerful. It is allowing your applications to adapt to changing integration requirements involving physical models. We also saw that how live data is actually improving the agility of the application. We've seen the live data improve the agility of the application, which is reducing your implementation and maintenance costs. And what that ultimately means for you is an increased ROI. So with that, I'm going to hand it over to Kaleem, who's going to be talking about some of the additional live data capabilities that I did not touch on.